There are trillions of stars, planets, and galaxies in space, most of which even our most advanced space technology hasn't been able to capture yet. But about 2.5 million light-years away from planet Earth, there's a spiral galaxy that can actually be seen by the naked human eye. In fact, it's one of the most distant objects in space that we can actually see with our own eyes completely unaided. This close neighbor galaxy has already begun colliding with our Milky Way, and in the near future will merge with it to form a completely new galaxy altogether. Welcome to Factnomenal, and in today's video, we take a journey to the fascinating world of the Andromeda Galaxy and what the great collision with our Milky Way could mean for life as we know it. The Andromeda Galaxy is one of the most famous galaxies in astronomy, a close second after our own home galaxy, the Milky Way. Despite being so close to us and one of the easiest to spot in the night sky, if you know exactly where to look, just a couple of centuries ago, astronomers had absolutely no clue that our spiral neighbor existed at all. Initially, Andromeda was simply believed to be just another one of the millions of so-called nebulae in space and wasn't really considered to be of much significance at the time. The earliest known record of the galaxy appears in the year 964 in a book called Book of the Fixed Stars, which was written way back then by Persian astronomer Abd al-Rahman al-Sufi. French astronomer Charles Messier mentioned it in his famous Catalogue des Nébuleuses des Amas d'étoiles, a catalogue of astronomical objects to be on the lookout for. These Messier objects were simply listed by him at the time, since Messier himself wasn't so interested in them as he was busy comet hunting. Little did he know that in listing out all the non-comet objects that seemed to frustrate his hunt for comets, he had already discovered something of far greater significance. But comets were all the rage at the time, so we can hardly blame the guy. But the prominence of Messier 31, as it was known back then, made it an object of particular fascination for all astronomers, as they couldn't quite wrap their head around what it could possibly be. It didn't quite fit the standards to be classified as anything they were looking for or knew of. British astronomer William Herschel too was extremely taken up with the object and stated that it is perhaps the closest of the great nebulae in the universe, after noting the faint reddish hue in the core region of the galaxy. Because honestly, how else were they supposed to make sense of its size and brightness in the sky? The first ever photographs of the galaxy were also taken in 1887 by Isaac Roberts from his very own private observatory in Sussex. The supposed nebula M31 also was factored into the great debate between astronomers Heber D. Curtis and Harlow Shapley in regards to the scale of the universe. Curtis was of the opinion that the spiral nebulae, like the Andromeda Nebula or Messier 31, were actually completely different galaxies, and that the Milky Way was just one galaxy among many. On the other hand, Shapley strongly disagreed, arguing that the nebulae were simply spiral pockets of gas, and there were no galaxies, just simply the universe, that is, the Milky Way. Well, as we know today, Shapley's arguments didn't really age very well, but this was perhaps one of the first sparks that set off the idea that maybe, just maybe, the mysterious Messier 31 or Andromeda Nebula could be something else altogether, something larger, something they hadn't been looking for, another galaxy perhaps. And soon, the answer to this question would arrive, and it came in the form of one of the most important discoveries in astronomy, made by none other than Edwin Hubble himself. Up until the 20th century, our perception of space and what lies in the great skies above was extremely limited and fell only within the bounds of the Milky Way. Hubble's curiosity led him to the Mount Wilson Observatory in California, right to the world's largest telescope at the time, the 100-inch Hooker telescope. Here, Hubble used the telescope to observe faint, fuzzy, cloud-like patches of light that were then broadly labeled as nebulae. When he turned the Hooker telescope in the direction of the Andromeda constellation, it completely transformed the field of cosmology. During his observations, he uncovered his first Cepheid variable star, a type of star used to measure out distances in space based on how it changes and varies in brightness. By charting the various changes in the star's brightness, he soon discovered that the Cepheid variable stars in Andromeda were actually much farther away than those lying in the Milky Way. After studying this contrast in distance, he came to believe that the so-called Andromeda Nebula was not just some great nebula floating out there in space, but rather another whole entire galaxy in its own right. Using this technique, he studied other so-called nebulae in the region and was surprised to find that there were actually millions of galaxies that existed beyond our own, perhaps for the first time ever proving just how much is out there, how little we know about the world beyond our own galaxy, and how terrifyingly large and endless space is. The discovery of the Andromeda Galaxy took years and years of data, observation, and debate, all to find that a large spiral galaxy, much like our own, was sitting just a few light years away, staring right back at us this entire time. The Andromeda Galaxy is a barred spiral galaxy sitting some 2.5 million light-years away from Earth in the constellation Andromeda, officially named Messier 31, or even at times referred to as NGC 224. It's one of the closest galaxies to our own Milky Way. Along with the Triangulum Galaxy, which is 2.7 million light-years away, and our own galaxy, it's the largest galaxy in the local group, which consists of about 30 galaxies. When it comes to its dimensions, our galactic neighbor stretches out much more than our own galaxy, with a diameter of 220,000 light-years. To put that into perspective, the Milky Way has a diameter of roughly about 100,000 to 175,000 light-years. The galaxy itself is thought to be at least about 10 billion years old, having formed through the merger of several smaller proto-galaxies over the eons. The Andromeda Galaxy's mass has always been believed to be substantially much larger than the Milky Way's, but recent data has shown that this isn't really the case after all. The two galaxies, in fact, share similar masses, despite the difference in size. When observing the Andromeda Galaxy, you'll find that it has a very active galactic nucleus with a dense cluster of stars near its center. Images taken by the Hubble telescope show 2 points of concentration, with a bright concentration just a little off its true galactic center being the second point of concentration. It's this second point that's home to a supermassive black hole that was recently measured to be equivalent to between 110 and 230 million suns. It's quite typical for a spiral galaxy of this size to be actively devouring small galaxies in its proximity. There are currently thought to be 460 globular clusters in the Andromeda Galaxy, which indicates that it is in fact quite the active cosmic cannibal. Home to trillions and trillions of stars and shrouded in gas and dust, this spiral giant of a galaxy is impressive in its own right. It's no secret that humankind has been forever curious about life beyond our planet, and that brings us to the question of whether our galactic neighbor, having so many similarities to our Milky Way, could possibly be inhabited. Though there are certainly thousands, if not millions of planets orbiting around their main stars there, much like our planets orbit around the Sun, there have not been any confirmed exoplanets found there as of yet. As you probably already know, it's extremely difficult just to spot and study exoplanets that are outside of our solar system but still within our galaxy, though we are getting better at it. There have been several reports of one good candidate in the Andromeda Galaxy for an exoplanet called PA99N2, but as of now, we have very limited knowledge of it. As far as finding an Earth 2.0, the best chance that a planet has to be able to sustain life is if it's located within the Goldilocks zone, also called the habitable zone of a star system. Perhaps with advances in optical lensing and other technological advancements, as well as future missions, we might soon learn whether Andromeda hosts any habitable planets of its own. But what makes it so interesting, besides the fact that it's so close to our Milky Way? What is so remarkable about the Andromeda Galaxy that has astronomers and scientists constantly observing and monitoring it? Well, probably the fact that Andromeda and our Milky Way are set on a collision course with each other, and the cataclysmic event is destined to change our worlds and galaxies forever. Galaxy collisions are not a new phenomenon in space. In fact, collisions between planets, asteroids, galaxies, and other nebulae are probably happening right now even as you watch this. But they're probably so many light years away that it would make little to no difference to us here on planet Earth. There are several types of collisions as well, with gravitational collisions between galaxies being one of the most fascinating. Galaxies are held together by mutual gravity, and they orbit around a common center. It's extremely common for there to be interactions between galaxies, especially between a giant and a satellite galaxy. This usually happens as a result of one of the galaxies moving a little too close to the other, to the point that the gravity of the satellite galaxy will attract one of the giant galaxy's spiral arms. Sound a little terrifying? Well, in a sense it is. And this is exactly what's going to happen in the future with the Milky Way and Andromeda, the two dominant giants of the local group. But these collisions are extremely normal, and in fact, Andromeda itself is believed to have collided with at least one other galaxy in the past. Our own Milky Way is no exception, and has most definitely merged or gobbled up between 5 to 11 smaller galaxies during its entire lifetime. Even smaller, lesser-known galaxies, like the Sagittarius dwarf spheroidal galaxy, for example, are colliding with the Milky Way and merging with it right now. Of course, when you hear the word collision, your immediate thought that comes to mind is mega-uber explosions or something like a Big Bang on a smaller scale, with a burst of energy and everything being blown to smithereens. Well, it's definitely not quite so sudden. These are more like slow-motion collisions, but there are still some quite extraordinary consequences. What you can expect to happen is for some stars to be thrown out of their galaxies, while others will be destroyed as they crash into the merging supermassive black holes. The intricate spiral structures of both the galaxies will be completely altered, as in the end they merge to form one big elliptical galaxy. The collisions of the two galaxies will give birth to a completely new galaxy, and a whole bunch of new stars will be born as a result of the violent collision. In most cases, larger galaxies tend to retain most of their structure and properties, while the significantly smaller galaxies are completely stripped apart and absorbed into the larger ones. Though we may not feel it, our galaxy is actually hurtling through the universe at 1.3 million miles per hour and is destined to crash into its neighbor, the Andromeda Galaxy. While the two spiral galaxies are at a happy, safe distance of around 2.5 million light-years at the moment, it won't be that way for too long, relatively speaking. The Andromeda Galaxy is headed right towards us at 68 miles per second. While on Earth that might seem fast, in reality it's estimated it will take at least 4 billion years for them to collide. Add another 2 billion years to that, and astronomers have predicted, with the help of data and simulations, that these two completely separate spiral galaxies will transform into one giant elliptical monster galaxy. The predicted new galaxy has been given the name Milkomeda or Milkdromeda, which might be better, but that's all still up for debate. The collision of the two galaxies will happen slowly and will lead to the birth of a whole bunch of new stars. The two supermassive black holes sitting at the centers of the galaxies will also likely eventually merge with each other. What's so incredible about this collision is the fact that we've known about it for over 100 years now, starting from the 1900s, when the wonderfully named astronomer Vesto Slipher predicted that the Andromeda Galaxy was headed straight towards our very own Milky Way. Ever since, telescopes and observatories all over the world have been monitoring and collecting whatever data they can on our spiral neighbor to see if there's anything we can see to give us a better picture of what's coming. Research teams have put together simulations to see what a possible collision would look like and whether or not it would be a head-on collision or just a brush by. The amazing and stalwart Hubble telescope was able to collect the data necessary to confirm that there really would, in fact, be a collision between the two galaxies in the future. It's rather fascinating how it was Edwin Hubble himself who finally established that the Andromeda Nebula was no simple splotchy blob of whatever, but in fact an entire galaxy of its own. And here we are, years later, using the telescope named after the great astronomer to yet again confirm that same galaxy's fate. By the time that happens, though, it's unlikely that humankind, at least in its present form, will be around to witness one of the greatest events ever to occur in our neck of the woods, a spectacular light show that will completely take over the night sky for millions of years. By then, the sun will have already grown so incredibly hot that there will be no life left on Earth. But new data and research published in the Astrophysical Journal shows that the collision between the galaxies has, in fact, already begun. So I guess we could say that we were here for the beginning of the great event. Andromeda and the Milky Way galaxies, along with many others, sit enshrouded in a large envelope called a galactic halo. This bubble-like halo consists mainly of gas and dust, as well as numerous stray or orphaned stars. Detecting these halos is extremely difficult, as they're extremely faint. Andromeda's halo was recently being studied by a group of astronomers when they were surprised to find that its halo is actually much larger than previously thought. This has led them to believe that the halos of both the galaxies are already touching and merging at the edges, pulling and tugging on each other. From our vantage point, it's extremely difficult to know and measure our own galaxy's halo, but considering their relative similarity in size, it's safe to say that they're indeed already brushing up against one another. So what about the other galaxies in the local group? It appears that the two galaxies won't be the only ones interacting in the collision and eventual merger. M33, aka the Triangulum Galaxy, will also have its own role to play. Although M33 won't be joining the merger itself, it's believed that at some point, due to gravity, the Milky Way will be engaged in a great cosmic dance with both Andromeda and M33. The stars in both of the galaxies will be affected by the merger, with some being thrown into a completely new orbit around the merging center. Though we may not be around to see it, it sure is fascinating to know what our galaxy has in store over the next few billion years. We have some new images from the Hubble of galaxy NGC 474, which lies roughly 100 million light-years away from us and comes in around 2.5 times the size of our galaxy. But what's getting astronomers really excited is its peculiar features: round, with layered shells wrapped around its central core. As research teams are eager to know what caused these shells, perhaps the answer might give us a better view of the futures of the Milky Way and Andromeda, which we won't be around to witness. The two will no longer be two beautiful spirals in the sky, but will give birth to an almost featureless elliptical galaxy. As the galaxies pull at each other, they'll become completely distorted, and central shells of material might even form just like we see in NGC 474. There are, of course, several theories surrounding the shells of NGC 474. One idea is that the galaxy perhaps interacted with another galaxy billions of years ago, which created the shells that we now see in a process that's similar to throwing a rock into a pond and watching as the ripples move away from it. This odd collision-caused shell feature is not unique to NGC 474, by the way. An estimated 90% of all known elliptical galaxies have these features, which might be a huge clue for astronomers about their formation and previous collisions and mergers between galaxies and what we can expect for our own. Additionally, there's one rather specific hallmark of a merger: starburst knots. These are sites of star formation that occur in the wake of a merger, when clouds of dust and gas are pushed together, eventually creating oodles of hot young stars. Eventually, though, the birthing of new stars will slow down, and the new galaxy that arises from the merger will be a simple elliptical and rather boring looking compared to what the original galaxies used to look like, especially if they were big, beautiful spirals like Andromeda and the Milky Way. This, in a nutshell, is what happened with NGC 474. It shows us what the fate of our Milky Way will be, even if it's billions of years away, and humankind as we know it is no longer around to experience this glorious act of collision creation. That's all for today, folks. What do you think about the future mashup between Andromeda and our Milky Way? Let us know in the comments. Please don't forget to smash that like button and subscribe to our channel so you don't miss another video. Thanks for watching. We'll see you next time.